In this video, we're going to look at interpreting data from a histogram with continuous data. Kennedy collected data on the amount of hemoglobin in gallons per deciliter in the blood of 409 subjects. I'm going to highlight that in case we need it later. The histogram below shows the percent of subjects whose hemoglobin fell in the indicated ranges. Now, before we look at the questions, let's make sense of this histogram. So first, our horizontal axis is hemoglobin in gallons per deciliter. Okay, and notice that the bars start at the indicated values. So here we have 11.5. The bar right here says 12, whereas in other examples we might have had 11.5 underneath in the middle of the bar, and that bar would have corresponded to just the value 11.5. But here we have a continuous range of values, so this bar is anyone whose hemoglobin in gallons per deciliter was 11.5 up to 12, but we're going to put but not including 12. Okay. So the idea here is that any range between 11.5 and 12, so 11.67, 11.893, there's a continuous set of values in here, and that's why we're calling it continuous data. But our convention is for the endpoint values, we always include them in the next largest bar. Okay, meaning that 12 is included in this bar. Here, 14 to 14.5, this bar includes 14, but it doesn't include 14.5. The people who are 14.5 or higher, but less than 15 fall in this range. Okay, and now our vertical axis represents the percent of people, so not a frequency, but a percent of the 409 subjects that fell in each range. And again, when these are harder to read, we sometimes label them on top because this is 19.5, but that might be hard to determine by looking at the scale exactly. But the scale is still useful because it shows us how these all relate to each other relatively, meaning this one's small, this one's high, etc. So now let's look at our questions. What percent of subjects had a hemoglobin measurement of at least 14 and less than 14.5? Okay, so here's 14 and here's 14.5. So 14, but not 14.5, so less than 14.5 is this bar right here. And if we look at the height of the bar, that corresponds to 19.5, and that is a percent value. And we were asked for a percent value, so we're going to write 19.5%. Let's look at the next one. How many subjects had a hemoglobin measurement of 15 or greater? Okay, so I'm noticing two things. We want how many subjects. This is a percent, so we're going to need to convert that percent to subjects using this value. And then also 15 or greater. So looking over here, let's change colors. How about blue? So 15 starts right here. Okay, so 15 or greater would be 15 to all the values up to 15.5, including it. So basically these 1, 2, 3 bars in these 3 intervals. Okay, so 15 to 15.5 is 9.5, 15.5 to 16 is 4.8, and 16 to 16.5 is 2.5. So now we'll need to combine or add up these percent values to find the total percent. So it's 9.5 plus 4.8 plus 2.5. You could do this on your calculator, but let's do this by hand. 9 and 2 is 11, and these halves make it 12, plus 4.5 is 16.8%. So we know that 16.8% of the subjects had a hemoglobin measurement of 15 or greater. Now we want the number of subjects. So we need to find 16.8% of the subjects, which is 409. And we can find that by multiplying 409 by 16.8 over 100, or you can move that decimal if you prefer, and just multiply by 0.168. So 409 times 16.8 divided by 100. Okay, we have 68.712, and since this is people, I'm going to round this to the nearest whole person. So let's round this to 69 subjects. And I'll put a little approximately equal here too. Now let's look at the last one. A hemoglobin measurement of less than 12 may indicate anemia and requires further testing. How many subjects fall in this range? Okay, so less than 12, let's see where that's located. Okay, so here's 12. This bar includes 12 or higher, so not these values. We want strictly less than 12, which would be this bar right here. So we have 2.2%. And just like the last problem, since we want how many subjects, we want 2.2% of the 409. Okay, let me change colors since we're running out of room. So 409 times 2.2 divided by 100. Okay, so that's a percent written as a fraction. I made a little more space there. So 409 times 2.2 divided by 100, and we'll round that to 9 subjects. Equals approximately 9 subjects.